Unit 0, Algebra Basics. So note here that we are not actually starting at the beginning in this course. We're going to start before the beginning, not with Unit 1, but with Unit 0. A big part of pre-calculus that you'll notice as we go forward is the importance of understanding the basics, of understanding prerequisite material. You can't build a house without a solid foundation. So for the first few weeks of this course, we're going to go back and review the basics of algebra. As a quick outline of what we're going to be looking at over these first few weeks, the first lesson that you've probably already seen with the video title would of course be Fun with Fractions. You've been studying fractions since elementary school. Some of you for some reason are afraid of fractions. I've never quite understood why someone is afraid of fractions with as simple as they actually are. But one's ability to work with fractions is a huge predictor as to whether they're going to be able to do advanced algebra. So we're going to take some time to review everything that you should already know about fractions and practice it a little bit. Then we're going to move on to a factoring review, which you've spent Algebra 1 and Algebra 2 focusing on factoring, so that will be a quick one. Lesson 3, we're going to look at 3 major questions that come up over and over and over that often students mix up when they're working with, especially the vocabulary they use: evaluating, simplifying, and solving. Oh my! Evaluating is not the same as simplifying, simplifying is not the same as solving, and solving is not the same as evaluating. So we'll look at each of those questions separately and how they compare to each other. And then we'll wrap up this unit with a review of solving quadratics. Again, another topic that you spent a lot of time on in Algebra 2, so that should be another quick one. Now, as I'm recording this video and posting it on the internet, and I don't intend on re-recording this every year, you'll notice here that the tentative test date is blank. I don't know what year it is that you're watching this video, so I don't know what day it is that you're going to have your first test date. So to find out when your actual test date is, it will always be posted on the board in class or posted digitally on Canvas or whatever digital platform we happen to be using at the time that you're watching this video. So here we go. Lesson 0.1, Fun with Fractions. At the beginning of every lesson, I'm going to post what the learning goals are for that particular lesson. Notice here we have 3 learning goals. Students will be able to add and subtract fractions with unlike denominators. Students will be able to multiply fractions. Students will be able to divide fractions. Now, all of this stuff right here, this is kind of a in-house record-keeping sort of stuff. Those are the actual state standards that I am addressing by each of these learning goals. Now, something I do like to point out here on this particular lesson is this 5 right here. This is actually the grade level that these particular standards belong to. Now, of course, I assume that most of you are not currently in 5th grade, but this is a review of everything that you've ever seen with regard to fractions. So we're going all the way back to elementary school. Now, of course, you started looking at fractions prior to 5th grade. But the level of work, I'm not going all the way back to your first introduction to fractions in 2nd grade where you're breaking pies into pieces and figuring out what the fraction is. No, we're doing actual operations with fractions. So I'm going to go back to 5th grade for a moment and then review all the way back to Algebra 2. Now, being that this lesson is going to be reviewing a lot of material, I've actually broken it up into 5 different parts. Now, I'm not always going to do that on any particular lesson. Most lessons are just a one and done particular lesson, or maybe even part 1 and part 2. This is just off the top of my head, I'm thinking that this is the most I'm going to be breaking a lesson into throughout the year. Again, that's simply because this is such a foundational topic and it's covering so many years of actual instruction. I've broken it into 5 different parts. So when you look at the assignment for lesson 0.1, you're going to see a separate assignment for each one of these parts. Actually, except part 1 and part 2, I've combined those into a single assignment. So 5-part lesson, there are 4 separate assignments for this lesson. I would recommend watching the lesson video for each part 1 and 2 you can watch together, and then complete the assignment before moving on to the next part of the video. So let's begin lesson 0.1, part 1, basic operations. Now, because this is all prerequisite information, this is all stuff that you already know, stuff you've been practicing for years, I'm not going to start with any explanation. I'm just going to give you 4 problems that I want you to complete on your own. You're going to have exactly 90 seconds. You don't need to pause the video or anything. I've got the timer already set up within the video itself. So if you, hopefully you already have been taking notes as far as titles and stuff like that, so you already have pencil and paper ready to go. If not, go ahead and pause the video right here. Make sure that you have paper and pencil and you are taking notes, and then hit play, and then I'll show the 4 questions and start the timer. I assume you're ready at this point, so here we go. 3, 2, 1, go. All right, that's your time. Let's go ahead and look at the answers. Now keep in mind this is a video. You can pause and play at your own pace. So if I'm moving on and you're not ready for me to move on, remember, just hit pause. This is a video. You can also go back and replay things if you need to. Also, if you've never played with the playback speed on YouTube, if you go into the settings, you can actually change the playback speed. So if I'm going too fast, you can slow me down. If I'm going too slow, you can speed me up. For instance, anytime I'm watching an educational video, I by default set it to double speed because I'm used to listening to people speaking quickly. So if I'm speaking too quickly and you need me to slow down, go ahead and slow me down using the playback speed option. But if I'm speaking too slowly and you want me to speed up, then just use the playback button to change the settings. All right, so we have our 4 answers to the 4 questions that you just did. Hopefully you got all 4 of them correct because of course you are a pre-calculus student and I assume you know how to add, subtract, multiply, and divide fractions. Now if you made any mistakes, that's perfectly fine. It's been a long summer, for some longer than others, and maybe you need a little bit of time to get back into things, so don't be too disheartened if you got anything wrong. Hopefully you looked at it and even if you got something wrong, you know what you were doing. It's just you're just a little bit rusty. That's perfectly fine. That's why we practice. Now before I look closer at these problems and give you a little bit of tips, tricks, and advice, I want to take a moment to give you some tips, tricks, and advice on something that's not directly related to what's in front of us. I want to talk about good note-taking. Now, here is an example of good notes that cover this lesson up to this point. Now, look at your notes, look at my notes. Look at your notes, look at my notes. Now, again, my notes are what I consider good notes. Now, of course, you might be saying to yourself or saying to me out loud right now, well, that's just like your opinion, man. Well, my opinion is backed up by years of experience and a degree in math education. So your opinion doesn't matter at all to me. One of the guiding principles that I suggest that you follow when you're taking notes is that you remember, notes are not for you. Notes are for future you. Every action you take in general in life should not be about you. It should be about future you. Future you need to think of as an entirely different person. Every action you take should be to the benefit of future you. You don't want to get to a point where you wish past you had done something differently because it's too late. Past you is in the past. Always focus on taking actions that are to the benefit of future you. Note-taking is a good example of benefiting future you. Because as soon as you've written it, Past you doesn't matter anymore. Past you is long dead. The reason we take notes is so that future you can reference those notes. When you are at home working on your homework, you're not going to have the instructor there right next to you, but you will have your notes right next to you. So you want to make sure that your notes cover everything that future you could possibly need, and that your notes are easy to navigate. So notice, what was the first thing I put at the top of my notes? The unit title. We began a new unit today, Unit 0. In a few weeks, we'll begin Unit 1. And a few weeks after that, we'll begin Unit 2. By December, we're going to have a lot of notes in here, and you want to be able to quickly and easily find what you're looking for, because even though it's December, I'm still going to be referencing stuff that we talked about back in September. I do that all the time. I'll be in class and I'll be talking about a particular skill, and I'll say, hey, remember when we did that thing in lesson such and such on such and such date? I'm going to actually stop right there and wait for you to find that particular example in your notes. Someone who's taking good notes will be able to quickly find that topic. After the unit title, I put the lesson title, because the unit is broken up into lessons, and that lesson is broken into sub-lessons. So I have a lesson subtitle. So we just started part 1, basic operations, and then once we get to part 2, I'll put in another lesson subtitle. For each example, I'm going to label it as an example. And notice I'm going to abbreviate as much as I can. I didn't write evaluate and simplify. I wrote eval and sim. Again, notes are for future me. I'm going to abbreviate as much as possible as long as I know what my own abbreviations mean. As you get better and better at taking notes, it should actually get to a point where if you handed your notes to someone else, there's actually no guarantee that they're going to be able to follow your notes. Again, notes are for future you, not future someone else. If you were to look at my handwritten notes, I have a lot of abbreviations that I made up myself that really only I would understand. Abbreviations allow me to write more quickly and to use less space. So feel free to come up with your own abbreviations as long as you don't forget what those abbreviations mean. Now below the example directions, of course, I provided the actual examples that I just completed, and I showed my work. That's one of the most important things to remember when you're taking notes. Again, notes are for future you. Show your work. The goal of notes is not to get the answer. The goal of notes is to demonstrate to future you how you got the answer. If all you do is write down the question and the answer, and then you forget how you got the answer, you just completely wasted space on your notes because they provide no advantage to you. Show your work. Show the steps. You don't necessarily need to show every step. You have to understand that future you is going to have some basic idea of what's going on. You're not teaching a kindergartner how to do fractions here. You are a high schooler that has some basic idea of how fractions work. So you don't need to explicitly show every individual step, but show enough so that you know future you will be able to look at your notes and say, I know what I did there. And it wouldn't hurt every so often to go back and look at notes from a few days ago to make sure that, hey, you still remember what you're writing there so that you know that you're still taking good notes. And then one other thing that I think is probably one of the most important things when I'm taking notes is I'm keeping my notes organized by using a notebook that has binding on it. I highly recommend spiral journals for note-taking. They allow me to keep my notes organized. They prevent me from losing pages of notes. I don't want to be in a situation where I'm looking for a particular page of notes and I have the page before it and I have the page after it, but then the page I'm looking for is completely missing. By using a bound notebook, I'm much less likely to lose notes, and all of my notes will be in the right order. And then when I'm done with the course, I can take this notebook, put it in my file cabinet at home that I assume I keep because I keep everything. And then next year, when I'm taking a course that's based on this year's information, I can just pull out that notebook and look up the skill I need to look up anytime I get stuck in my next course. And then one last thing that I highly recommend that you do when you take notes is leave some space. Again, you want to be able to easily read the notes in the future. When you try to conserve space by using small writing or by not skipping lines, everything kind of gets jumbled together and it's harder for you to decipher what it is that you are writing. Notice on these notes, there was only 4 questions, but I used half a page to demonstrate those 4 questions. I'm thinking about future me when I'm writing these notes. I want to make it super easy for future me to be able to decipher what's going on. It's just like when somebody's presenting a slideshow or a lesson, a PowerPoint lesson. Something you may notice is that a well-prepared lesson doesn't show you all the information all at once. It piecemeals it out to you. So for instance, on this particular slide, I didn't put all of these arrows up all at once because that's too much information for you to read all at one time. I gave it to you one piece of information at a time to guide you to look at what I wanted you to look at. When you have too much visual information in a small space, the brain doesn't know what to focus on, and instead of absorbing all of that information, it really absorbs none of it. So you want to limit the amount of information you have in a certain visual space. So leave space separating your examples, and you'll be able to better absorb that information at a later date. Now, just for comparisons, and as a non-example of good notes, here. Now, look at your notes, look at these notes, look at your notes, look at these notes. If your notes look like these notes, you are not good at taking notes. Make your notes look like these notes, not like these notes. Pretend that it's 3 months from now, and you find this piece of paper in your notebook. What unit was it from? What lesson was it from? What was I asking you to do here? Now, you may or may not be able to decipher what it is that you were asked to do here. But if you look at good notes, there's no doubt that you'll be able to decipher what was going on. On these notes, I just have questions and answers. What if I don't remember how I got from the question to the answer? Will these notes provide me any assistance? If you focus on taking good notes along with doing your daily practice, you'll find that upper level courses are that much easier simply because you put the work in advance. If you find yourself struggling later on this year, ask yourself, is it because I'm taking notes like this? So jumping back to where we left off, again, you've checked your answers. If you got all 4 of these answers correct without any trouble and you had time to spare, then feel free, just go ahead and jump ahead to example J. You can use the table of contents in the description below. If you had any trouble with any of these answers, then you're going to want to continue with the lesson from here. Now keep in mind that trouble may have simply been because you're a bit rusty or you're out of practice. Well, that's the point of practice. So make sure whether you are good or not good with these 4 questions that you are practicing every night. So let's start with adding, which of course, anytime I teach you how to add, I'm also teaching you how to subtract. Always connect in your mind. Addition, subtraction, and multiplication, division. Any rules that apply to addition also apply to subtraction. Any rules that apply to multiplication also apply to division. When you're adding or subtracting fractions, think of adding and subtracting fractions just like if you were adding and subtracting measurements. If I asked you to add 2 inches and 4 feet, sure, you could say 2 inches and 4 feet, or 4 feet, 2 inches. But I want it all in one unit. Well, you can't add feet and inches together because they're not the same unit. So with fractions, we have a rule about adding a common denominator. In order to add fractions, you have to have a common denominator. In order to add units, you have to have a common unit. If you don't have a common denominator, then you can't add them together. Just like if I asked, what's 2 inches plus 4 inches, you could say 6 inches. Well, 2 fifths plus 4 fifths equals 6 fifths. If you have the same denominator, if you have the same unit, you can just combine them together. So adding fractions means get the common denominator and then add the numerators together. Notice the unit does not change when you're adding or subtracting. On the other hand, if I asked you what's 2 inches plus 4 feet, that question doesn't make any sense because the units aren't the same. Just like if I have 2 fifths plus 4 thirds. The denominators aren't the same. In order to add fractions together, you have to have the same denominator. So when we don't have a common denominator, first step is to find the common denominator. Easiest way to find the common denominator is just to multiply the 2 denominators together. 5 and 3 gives you 15. So the common denominator is going to be 15. Now, technically, this is referred to as the least common denominator. 30 would also be a common denominator. 90 would also be a common denominator. Any common denominator will work, but the bigger the number, the more complex the problem. So you always want the least common denominator. Now, because I'm changing the denominators to 15, I have to change each fraction one at a time, starting with 2/5. I'm going to ask myself, how did I turn the 5 into a 15? Well, I multiplied it by 3. And a rule that we have about fractions is whatever you do to the denominator, you also do to the numerator. So if I multiply the bottom by 3, I'm going to multiply the top by 3. And I'm going to do the same thing to the 4/3. In order to get from 3 to 15, I multiplied by 5. So I'm going to multiply top and bottom by 5. So the first fraction, 2/5, becomes 6 over 15. And the second fraction, 4/3, becomes 20 over 15. So whereas I couldn't combine 2/5 and 4/3, I can combine 6/15 and 20/15. 6/15 plus 20/15 would be 26/15. Now always remember, you're not done until you're done. Once you've combined the two fractions, double check, can you reduce the two fractions? Because just like multiplying top and bottom by the same number, you can also divide top and bottom by the same number. Like I said before, any rule that works for addition also works for subtraction. Any rule that works for multiplication also works for division. If you can multiply top and bottom, you can divide top and bottom. So looking at these two numbers, 26 and 15, ask yourself, is there a number that can be divided evenly out of both of them? No, there is not. One thing I would do is look at the smaller of the two numbers, 15. In your head, factor out 15. The only thing you can pull out of a 15 is a 3 and a 5. If either of those numbers can be also pulled out of 26, then you can reduce it. Does 3 go into 26? No. Does 5 go into 26? No. So I'm done. Don't just stare at it and hope that the number magically appears to you. Go through it methodically. Look at the smaller number, factor the smaller number in your head. If any of those factors go into the bigger number, then you know you can reduce. All right, here is another example. Go ahead and pause the video here, hit play when you're ready. Okay, so hopefully you found the common denominator pretty quickly. Not 50, although 50 would be a common denominator, it's not the most efficient common denominator. You can always find a common denominator by multiplying the two denominators together. 5 times 10 gives you 50. But in this case, the 5 goes directly into the 10, so the least common denominator would be 10 itself. So I don't have to make any adjustments to the 4/10, but I do have to make an adjustment to the 2/5. I multiplied the 5 by 2, so that means I need to multiply the top by 2 as well. So that's going to give me 4/10 minus 4/10. Well, what's 4 minus 4? 4 minus 4 is 0/10, but we're not going to stop there. Don't ever give me 0 over a number. That's redundant. 0 divided by 10 is 0. If you have 0 on the top of the fraction, the answer is 0. 0 on top, the answer is 0. Do not leave 0 over a number. The answer is 0. All right, moving on. Here's a couple of multiplication problems. Remember, the rules for addition and subtraction are not the same as the rules for multiplication division. Addition subtraction is one game, multiplication division is a different game. Addition subtraction is baseball, multiplication division is basketball. Sure, they both have the same general idea that the more points you have, you win, but if I show up to a basketball game with a baseball bat, I'm going to be breaking the rules very, very quickly. So when I'm multiplying, common denominators are off the table. I do not need common denominators in order to multiply. When I'm multiplying fractions, just multiply straight across. 2 times 4 is 8, 5 times 5 is 25. But again, you're not done until you're done. Double check, 8 and 25. Can I reduce that? Well, 8 can be broken up into 2 and 4. Can you pull either of those out of a 25? No. Now, in this case, it wouldn't have been too much hassle to instead of breaking up the 8, to break up the 25. 25 is 5 times 5. The only thing you can pull out of a 25 is 5. Can you pull a 5 out of an 8? No. So confirmation that that is the simplest answer. Now, take, let's say, 3.5 seconds to answer question I. 3, 2, 1.5. Hopefully you got 8 over 15. All right, take another 3.5 seconds. 3, 2, 1. All right, 8 over 50. But this time we are actually not done because 8 and 50 have a common factor. Remember, after you've done the problem, double check, can you reduce that any further? Both 8 and 50 are even numbers, which means I can divide by 2. If I divide both top and bottom by 2, I get 4 over 25. You're not done until you're done. Double check one more time. Can anything be pulled out of 4 and 25? 4 is 2 times 2, 25 is 5 times 5, nothing in common. That's my final answer. Now, as simple as that was, I recommend doing this type of problem a different way. Let's look at this same problem 2 other ways. My recommendation is to always simplify first. Now, I could easily, with these numbers, I could easily just multiply straight across and simplify. Yes, I agree with you. These are small numbers. Just multiply across and simplify. That's perfectly fine. But you're always wanting to think ahead to possible future problems. If these numbers were a lot uglier, you probably wouldn't want to multiply straight across first. One of the rules that we have available to us on multiplication and division is the ability to simplify in several different ways. Now, of course, you could simplify fractions when you're adding or subtracting, but you can only simplify them one way, vertically. With multiplying and dividing, we have the added benefit of being able to simplify diagonally. 2 and 10 can be reduced to 1 over 5. Feel free to do that as your first step. So instead of waiting to simplify at the end, let's go ahead and simplify at the beginning. Now notice if I multiply straight across, 1 times 4 is 4, 5 times 5 is 25. We get to the same answer, but we didn't simplify at the end, we simplified at the beginning. Now, of course, instead of dividing the 2 and the 10, I could have divided the 4 and the 10, divide them by 2, and 4 over 10 becomes 2 over 5. Then multiply straight across, we still get 4 over 25. So you can either simplify at the end, you can simplify in the beginning diagonally, or you can simplify in the beginning vertically. Doesn't matter where you simplify, what matters is that you simplify somewhere. But as the numbers get bigger and bigger and bigger, it's so much easier to simplify at the beginning than it is to simplify at the end. So my suggestion is to just always simplify first. All right, so speaking of slightly more challenging problems, here's another one. Now, if you're of the mindset that you don't want to consider any nuance to particular problems, for instance, I'm going to do the problem in using method A if it looks like this, but if I'm going to looks differently, I'm going to use method B. If you just want to do every problem the same way so that you don't have to think about different ways of doing problems, then you're going to look at this problem and you're just going to multiply straight across and you're going to get incredibly big numbers. Now remember, it says up here, you may not use a calculator. No calculators allowed on this problem. So your stubbornness to allow for different ways of approaching different problems is actually going to make this problem more difficult. Whereas those of you who are willing to accept that depending on the complexity of the problem, a different method may actually make the problem easier, you're going to look at this problem and immediately see a few things that will allow you to simplify. Now, one thing you want to remember when you're multiplying fractions, the order doesn't matter. So if this is fraction A times fraction B times fraction C, it doesn't matter what order you do this in. This could be the same thing as this, which could be the same thing as this. It doesn't matter what order you do things in. So you could multiply the first and the second together, or you could start by multiplying the first and the third together, or you could multiply the second and the third together. It doesn't matter what order you do these operations in because it's all multiplication and division. When you're looking at order of operations, multiplication and division can be done at the same time. You do not have to do multiplication before you do division. You can do division before you do multiplication, and you can multiply and divide in any order. So I'm going to start by looking at the three numbers on the top and comparing to the three numbers on the bottom. Remember that I can simplify vertically and I can simplify diagonally. Thus, I can simplify any number from the top with any number on the bottom. So if I wanted to start by looking at the 12 and the 36, sure. Or I could also start by looking at the 12 and the 64. Or I could start with the 40 and the 64, or the 300 and the 64, or the 300 and the 25. It doesn't matter where you start. Any number from the top with any number from the bottom. So what I'm going to do is I'm going to start with the first thing I saw, the 12 and the 36. 12 goes into 36 3 times. So if I divide the top by 12 and the bottom by 12, the 12 becomes a 1, the 36 becomes a 3. So immediately I made this problem easier. Had I started with 12 times 40 times 300, I don't know what that is off the top of my head. But if I divide the 12 out from the top and the bottom, well, now it's not 12 times 40 times 300. It's 1 times 40 times 300, which is a much simpler multiplication problem. But let's not stop there. Let's keep going. So next I'm going to look at the 40 and the 64. Now with the 40 and the 64, the 40 doesn't go directly into the 64, but there are common factors between 40 and 64, and it doesn't matter which common factor you pick. Some of you will stare at a fraction, trying to figure out how to simplify a fraction for minutes and minutes until you figure out what the greatest common factor is between two numbers. It does not matter when you're simplifying fractions. It does not matter whether it takes you 1 step to simplify the fractions or 10 steps to simplify the fractions. The point is to simplify the fractions, not to simplify it in the fewest number of steps. So when you're looking at 40 and 64, you may look at these numbers and say, hey, 40 and 64 have a 4 in common. 40 is 4 times 10, and 64 is 4 times 16. Go ahead, divide it by 4. Or you might say, 2. They're both even, so divide the top by 2, divide the bottom by 2. That's perfectly fine. I don't care what you divide by. Just divide by something. Now in this case, I immediately recognize 64 as a perfect square. 64 is 8 squared, and it just so happens that 8 goes into 40 as well. So I went ahead and divided both by 8. It also just so happened that that was the greatest common factor. But I am not looking for the greatest common factor when I simplify. I'm just looking for any common factor when I simplify. And the next thing I notice is the 25 and the 300. Anytime I see 25, I think about quarters. So 25 cents into 300 cents, or $3. How many quarters go into $3? Well, $1 is 4 quarters, so $3 would be 12 quarters. So I can divide top and bottom by 25, and I have this. Now notice, just by simplifying before I started, instead of having these large numbers, 12, 40, 300, 25, 36, and 64, I have much smaller numbers to work with. The ones no longer matter. I can completely ignore them. And then I just have 5 times 12 on the top and 3 times 8 on the bottom. Those are much smaller numbers, and notice at no point have I needed a calculator to do this. But of course, I'm not done because I could keep going. I notice 12 and 8 could simplify further, or 12 and 3 could simplify further. It doesn't matter which one I do. Either one is fine. Pick one and go with it. I went with 12 and 8 reduces to 3 and 2. And hey, look at that. 3 on the top, 3 on the bottom. Let's simplify that further. Anytime I get down to 1, that means I can completely ignore it. So by doing no multiplication whatsoever, I have made this problem so simple that I actually literally have to do no multiplication whatsoever. The answer is 5 over 2. All I did was simplify, simplify, simplify until I had nothing left. Now, of course, the better you know your times tables, the easier this is going to be. So if you look at that and you don't obviously see what goes into what, then it simply means you need to practice your times tables more. But at the end of the day, the simplifying process is going to be much quicker than multiplying it first and then simplifying. Now, just to point out that it doesn't matter what order you do things in, let's do that problem again, but simplifying in a completely different order. So this time what I'm going to do is I'm going to start with the 40 and the 64, and instead of dividing by 8, I'm going to divide by 4, because I know that 4 goes into 40 and I know that 4 goes into 64. And I'm just going to go around randomly. I know 336 have a 3 in common. Now, of course, I could do better than a 3, but I'm not worrying about that. And the 12s, immediately, I'm just going to cancel those out completely. And typically, I'm not going to bother writing a 1. I'm just going to cancel it out and ignore it from that point forward. I know that 25 goes into 100 4 times. I know that 4 goes into 16 4 times. And I know that 10 and 4 have a 2 in common. And look at that. Final answer, 5 over 2. It does not matter what order you do the simplification in. As long as you do it legally, you're going to get the same answer no matter what order you do it in. Now, before we move on to division, I want you to try that one more time. So just like before, go ahead and multiply this through by simplifying first. Pause here, hit play when you're ready. All right. Does not matter what order you do things in. So what I'm going to do, I see the 20 and the 40 immediately. I'm going to go ahead and get rid of those. 20 goes into 40 2 times. I then may look to see if the 2 can simplify any further with anything else on the bottom. 27 and 49 are both odd, so that means that 2 is going to be there for the long haul. Next, I look at the remaining numbers. 27 and 28 have nothing in common, but 28 and 49, they both have a 7 in common. 49 is, of course, 7 squared, so if I divide by 7 and divide by 7, I'm going to be left with 4 over 7. Remember that the 4 is on the top, so don't try to simplify the 4 and the 2. Next, I'm going to look at the 81 and the 27, both of which are divisible by 9. So if I divide by 9, divide by 9, I get that. But then I see, just because I divided by 9 doesn't mean that I was done. 27 and 81, sure, they're both divisible by 9, but I can go further and divide by 3. Because 27 goes into 81 3 times. You don't necessarily need to know that from the get-go to be able to get the answer. Just simplify what you see and then see if you see anything else. You don't necessarily need to simplify in one step. If you can simplify piece by piece by piece, go for it. Just remember to look to see if you've simplified it fully before you move on. And then double check, is there anything else I can simplify? The only thing left on the bottom is a 7, which is of course a prime number, and I don't have any 7s on the top or anything that that has a 7 that factors into it. So let's finish this up. 4 times 3 times 2, that's going to be 24 over 7. All right, let's move on to division. If you were good with this on those preview questions, feel free to go ahead and jump to part 2 of this lesson. Otherwise, let's go ahead and wrap these last 2 questions up. So remember, with division, the thing to remember is keep it, change it, flip it. We're going to keep the first fraction as it is. We're going to change division to multiplication, and we're going to flip the second fraction. Instead of 4 over 5, it's going to become 5 over 4. Then it's no longer a division problem, it's a multiplication problem, and follow the rules of multiplication. Before I start multiplying, I'm going to notice the 5's cancel out, and the 2 over 4 reduces to 1 over 2, so the only thing left on the top is 1, the only thing left on the bottom is 2. For question N, pause here, play when you're ready. All right, so keep it, change it, flip it, gives me times 3/4. I'm going to notice the 6 and the 4 reduces to 3 over 2. Anything else reduce? I don't see anything else that reduces, so 9 over 10, final answer. Now that's going to wrap up part 1, but before you move on to the assignment, I'm going to go ahead and suggest that you knock out part 2. Part 2 is going to be a bit shorter because it's just a special case of part 1. That's why I grouped them together in the assignment. So once you finish watching the part 2 video, then you'll do the assignment for parts 1 and 2 together before moving on to part 3.